When first reading this task, it's somewhat deceptive. It's asking us for some very, very straightforward mathematical calculations. But when we lift the lid on this task, we see that the manner in which we solve the problem is somewhat tricky to think about. One of the strategies that may have entered your head when approaching this task is to keep a list of all of the numbers as you go along. So every time the user types in a number, it would be a real number, that number is stored in a list. And as time goes on, that list will eventually stop because somebody will enter in the number 0. Now, upon entering the number 0, we ideally don't want to add it to the list. So having built up a list of numbers, we then set about calculating the highest, the lowest, the sum of the numbers, and then the mean, which would just be the sum divided by the length of the list. All of these things seem fairly straightforward. I would argue that there isn't a need to store all of the numbers as we go along. If this list of numbers were to get incredibly long, such as a list of temperature readings being read in a weather station every 30 seconds over a period of years, then working out the highest, the lowest, and the sum and so on could become quite a tedious algorithm. And it could become very heavy on the computer, number one, because it has to store so many numbers, and number two, because it takes so long to revisit all of the numbers in order to calculate the highest, the lowest, the mean, etc. So here's a slightly different angle on the problem. As we go along filling in the numbers, I'll just leave the list of numbers on the screen. As we go along filling in the numbers, what we do is we start off by assuming that the highest number we have ever met is the number 0, and then this list of numbers will be positive real numbers. So each time we fill in a number, we say to ourselves, well, is this new number higher than the previously thought highest? And in this case, yes, it is. We read in our next number, it's not higher than it, so we leave the highest alone. The third number is not higher than it, so we leave the highest alone. But the fourth number does turn out to be higher than it, and so we update the highest number. In this case, it doesn't matter that we have lost the previous values without storing them. You can use exactly the same approach for the lowest number, and in this case you would start off with an extremely high number, some sort of ridiculously high number, and then every time you bump into a new number, it's going to overwrite that one. Now, a challenge here would be, how high do we go here? Because there is no stipulation in the task to say what the range of numbers would be. But we could make a fairly hazard a reasonable guess here if we stick to something really, really high. So we'll want our highest number to start off with 0.0 and our lowest number to start off with an extremely high number. About the total of the numbers, we can't use the word sum because it comes up as a keyword of the language, so we'll use the word total instead. The total can start off with 0.0, and then as we go along we simply add up the numbers. So we record 7.8, and then 7.8 plus 4.5 would be 12.3. And so we just keep a rolling total as we go along, and then this would become 16.7 once we've added that in. And so we don't have to keep the breakdown of the original numbers, we only have to store their total. In order to calculate the mean, what we would need to know is how many numbers have been entered so far. And so I'll create a variable called quantity. It would start off at 0, and then once you've typed in 7.8, that would increase to 1. And then after typing in 4.5, that would increment, we could say, to 2, and so on and so on. So far here we've entered in 3 numbers, and so when the total is 16.7, the quantity of numbers is 3, and so you can recalculate the mean at that point and say what is 16.7 divided by 3. However, that task can be delayed until the end, until you've typed in your 0, and at that point the mean can be calculated once and once only. There's no need to recalculate the mean as we go along. And so, in order to solve this problem, we don't really need to store all of the numbers, we just need to update our various variables as we go along during the input. With that in mind, let's keep this in as a comment just to give us something to guide us. Let's say that the highest number is going to start at 0.0 because we know that this is going to jump to a higher positive number. Let's leave the lowest number at something ridiculously large. let's set the total to 0.0 in the beginning, and let's set the quantity to 0 in the beginning. In order to read in the various numbers, we're going to use a condition-controlled loop. We call it condition-controlled because we don't have any way of knowing in advance what the quantity of numbers is going to be. So in this case, Python offers us the while loop syntax, so that's what we're going to use. Let's begin by asking ourselves, what is the condition under which we're going to stop the loop? Well, the idea is that the user is going to input a series of real numbers. So let's kickstart the process by doing what's called a priming read. And this means that we've read in the value once just to get things going. So I'm going to call it real because it's not a keyword of the language. And I'm going to say that I'm going to use input and I'm going to say enter a positive real number. Leave a space, close the quotes. The input function in Python always reads in your inputs as a string. Therefore, we're going to have to typecast this to the data type float in order to convert it to a float. We can assume that the values are always going to be valid. Next, we say while the real number is not equal to 0. Now, we could write it in real number syntax as well. So while the real number is not equal to 0, what are we going to do? Well, we're going to update our various variables. So we're going to say, let's take a copy of them. Okay, we're going to say if the real number that we have entered is greater than what we think is currently the highest number, then the highest number now needs to change and become the real number. But if that's not the case, there's no work to do. Okay, so step 1 in our program is that we update the highest if necessary. Okay, we repeat that concept then on the next part, and we say using copy and paste here, we can actually copy and paste this entire structure, comment included. Okay, next we're going to update the lowest number if necessary. So if the real number that we have just typed in is less than what we originally thought was the lowest number, then that means that the lowest number also needs to be updated. Next, we're going to update the total. Updating the total is always going to happen, so no if statement is required. Update the total. And very simply, the total becomes equal to the old value of total plus the new real number that has just been keyed in. And finally, we update the quantity. And scrolling down, let me just create a bit more room here. Updating the quantity then means we take the quantity and we simply add 1 to it. It becomes equal to the quantity plus 1. Okay, so while the real number that has just been read in is not equal to 0, that means that we can go ahead and do all of these tasks. At the last minute, we now read in the next real number by repeating this line of code, which was originally used for our priming read. Again, the word priming read, the phrase priming read, means that we're going to input a value into a variable to get things going with the while loop. Okay, let's imagine that on the second input the user does enter the value 0.0. That means that the while loop will say, real number is equal to 0.0, therefore this will evaluate to false and no further work will take place. An unfortunate eventuality here would be if the first number that the user keyed in was a 0, and that's something that we're going to have to bear in mind, because if the user does type in a 0 initially, that means that none of these updates will take place, and that means that all of these values will stay exactly as they are. Okay, so we'll deal with that eventuality later. Okay, at this point then, having executed the while loop around and around and around, eventually the user will type in a 0 as the real number, and that will mean that the highest value will be whatever the highest value was all along. The lowest will also be the lowest that it was all along. The total will store the actual total without adding an additional 0. And the quantity reached will not increment whenever you type in the 0, because the 0 will be entered and you'll not re-enter the while loop. So the quantity will also be correct. At this point we'll be able to output our findings, and we'll be able to say the highest is equal to, and then we'll join on the value of the highest variable. That will need to be typecast into a string because I've opted to use the plus symbol for concatenation. We'll take a copy of that, and we'll say then that the lowest is equal to whatever the lowest is. The third one will be the total. The sum of all the numbers is going to be given as the total. And finally the mean. In order to calculate the mean, we take our total and we divide it by the quantity of numbers that was entered. This is also a point of danger if we never entered in any numbers. If the length of the list was 0 integers, then there's a risk that we would end up dividing by 0. So, before dealing with the unusual eventuality, let's try running the program to see if we have arrived at a working solution. Let's use a short list of test values. Let's try these three numbers. They are 7.8, 4.5 and 4.4. The expected outcomes should be calculated if we're about to do some testing. The highest value that we should be deriving is 7.8. The lowest value that we should be deriving is 4.4. The total of the four numbers is, it ends in a 7. And we say we're carrying a 1 in 4, 5, 6, 7, 8, 9, 16, 16.7. And finally, the mean of these numbers is going to be 16.7 divided by 3. So in order to do that, let's just use the calculator actually, just to make sure we get it accurate in case I do it in my head and make a mistake. Oop. I've done it on the calculator and made a mistake. So 16.7 divided by 3 equals, so it's 5.567. Okay, so let's comment out these expected outcomes. Alt and 3 on the keyboard does a quick job of that, and let's run this. Okay, so our positive numbers that we're going to enter are 7.8, 4.5 and 4.4. And now we're going to type in a 0 to terminate things. The values that are returned are 7.8 for the highest, 4.4 for the lowest, 16.7 for the total, and 5.567. This is a typical problem that we see with real numbers, where it cannot represent certain numbers accurately inside the computer because of the way that it stores real numbers. Therefore you get this unusual behavior. So we could force it to round to a certain number of decimal places if we wish. Okay. In order to improve the program and to deal with robustness issues, we may want to give some thought now to what would happen if you typed in a 0 at the very beginning. Well, if you typed in a 0 at the very beginning, if you say if real is equal to 0.0, then that means you're going to have to deal with the program very differently. In that case then, your highest, lowest, etc. are all going to be known in advance. And you can just go ahead and print them out without performing any of the calculations. Otherwise, you can proceed with entering your while loop, and I'm going to highlight everything for the rest of the program, and I'm going to use indentation by using the shortcut that exists here. Format is indent the region. Control and closing square bracket would have done that for me, but that means that the majority of the work is only going to happen if there is actually a list of numbers. So in this case, we don't need to output anything here. We're just going to say that we could say the highest is equal to 0, the lowest is equal to 0, etc. Or we could just take a different tactic here and say that, well, those four numbers maybe don't really make any sense. So we'll do both. We'll say we'll output these numbers just for the sake of outputting numbers, but even though there is something unsettling about that, we could just put in one more print statement just to say this list of numbers was empty, no data available. Okay, so either a statement like that, or if you have to generate numbers, then you could do it like that as well. And that gives us a final working solution.